three groups were further subcategorized into smoker or not smoker based on the sample that people are smokers and some people are not smokers. So this was like, it's another factor that came up. We didn't plan for this experiment for it. What we did, with the help of a professional nurse and with help with a certified clinical laboratory that is engaged in the clinical examination right away, we paid him and he did the analysis for us. We take the sample, blood samples, divided into two portions. One for the analysis right away for blood picture and pesticide residue analysis, and one for the serum separation for the hormones and some other biochemical parameters. The pesticide residue were done using the culture method, which is certified method by several companies that work in pesticide residue analysis, like Agilent. It's called quick, efficient, cheap, safe, rugged method. And we used it for the extraction of pesticide residues. Further, we analyze the samples using GC, gas chromatography, attached with mass spectrophotometry detector, so to get more specific and more good results, accurate. Thank you. For the blood picture, we used in the clinical laboratory, we use their technique and their machine to get the whole blood, white blood and differentials, red blood and differentials, and platelets and differentials as well. All parameters have been assayed for. For the hormones in the serums, we tested for the testosterone. We tested for T3 and T4, which is some reproductive and some thyroid hormones. What we found was, for pesticide residue analysis, all pesticides, this is a very, very long list of insecticides, herbicides, fungicides, nematicides, different kinds of pesticides that have been applied based on the best that is found. And the farmers that they apply the pesticides, they apply at least once a week. So they are engaged and they get in contact with all of this list all year around. All the pesticides have not been detected in the blood samples, which is a good thing. It means that the metabolism is working. But based on the detection limit, we have a detection limits here in nanogram. Maybe if we go further for more specific tools, we can find it in the blood samples. It's only except one herbicide that has been detected in about 3 volunteers, in the blood samples of 3 volunteers, and this herbicide is kind of new. It has been established 3 to 4 years ago, and it's been recommended by huge corporations, and it's been detected in the blood samples. What we found also that on white blood cells, the white blood cell has been decreased, which is an awkward, it should be increasing. But for the sprayers, it's been decreasing. And also for the smokers. If we see the negative control, the city inhabitants, the white blood cell is being decreased. So also the white blood cell differentials had the similar trend. They were decreased in the sprayer and the smokers, and samples of sprayers and smokers. Platelets as well. Platelets in the blood samples of the sprayers were drastically decreased. If we see 150 compared to 280, it's kind of more than 40% decrease. Red blood cells, it was increased, and this was significant based on a statistical analysis, and the comparison was done using the Dunnett specific comparison post hoc test. The Dunnett was used because we want to compare specific treatments to specific controls to see if there are any significance. Hematocrit and hemoglobin concentration also had similar trend to red blood cell, and it increased as well. Hormones, the hormones were chosen because based on literature, hormones has been disrupted by smaller doses. The major disruption in hormone activity was based on smaller doses. Maybe the higher doses will affect, but the effect won't have a simple trend, a flat trend or something. But it's the lower doses that affect hormones. That's why we choose some hormones to see if there is an effect. And also we found a decrease in testosterone and T4 thyroxine. For the analysis, statistical analysis, we want to see the very important parameters that we can concentrate in this one in the next study, so we can start our fast assay on spot toxic effect measuring. So the principal component analysis has categorized our parameters, all the parameters that we have studied, into different groups that be collective together. Anything that fall into this balloon, any one of them can give the same action, so we can use it as a parameter. So here, the platelet number came by itself, so it's a very good estimate for the toxicity. Here is the lymphocyte, neutrocytes, and came together as well in different dimension. And also white blood cell, mean cell volume, and mean platelet number, they came together here. Hormone thyroxine, they were different from T4 and T3, they were different. Testosterone came with the neutrophils. So what we came out from this one, that if we selected one parameter that is easy to assay, cheap, from these categories, it will save money, it will save time for fast detection of the toxicity on site. Further, we use the cluster analysis to categorize all the volunteers. The most interesting thing is that the volunteers categorized to the three groups that we used. The major categories you will see here, one cluster, one big cluster, that's the farmers. That's the people who do the spray application. And here are city, another cluster for the city inhabitants, and another cluster for the farmer who are in the area but they don't apply the pesticides. Further, each of this big cluster is being clustered in some other groups, some other trees, and some other branches of the trees. But the major effect, you can see that smokers came by themselves in one cluster, and non-smokers in another one. So it means that the sample we used may be sufficient to conclude that we can use one or two or three parameters of the parameters that we choose for our objective. So we can use them to further go and start establishing our fast assay on-site toxic effect measurements. What we came out from this study is that the lack of, I will show you now, I will show you in a moment a picture that you all will hate. But the lack of use of personal protective equipment while doing insecticide, pesticide application is a major concern in the third world, in developing countries. And the pesticide residue we didn't detect all the insecticides or pesticides in blood samples. Significant differences in white blood cells decreased. Pesticide alters some thyroid and some reproductive hormones. Smoking was, this effect came from nowhere because we didn't plan for it, but we saw it. It has a unique effect, meaning that city inhabitants, for example, who smoke, they have an effect equal to people who spray. Their white blood cell decreased in a similar way, in similar trend. Their hemoglobin concentration as well, and their hormones were affected even more than the pesticide applicators. Farmers who spray pesticide without being smokers, you can see a severe effect. But farmers who smoke, the effect was smaller. The multivariate analysis that we used was good to differentiate between groups of volunteers, and it was revealing an efficient way to categorize the parameters that we use for further selections. And this study is one of the series of studies that highlights the importance of here we need governmental intervention to make who applies pesticides is a registered applicator, because we lack of this in the developing world. It's not just in Egypt, in everywhere around the world you will see something like this. This is a picture from Egypt, and this is a picture from India. There is no use of the protective equipment at all. And even they are playing with each other like they are spraying each other with water. This is a toxic material, and they are playing with it. So the governmental intervention, the institutional intervention, it's needed for reduction of the pesticide poisoning. And thank you so much. Any questions?